In this video, we're going to review proportional relationships. And proportional relationships can be found in graphs, tables, and in rules or equations. And a proportional relationship shows that there's a direct variation between the y value and the x value in an equation where it's multiplied by some number, which is the unit rate or the slope. Now, for a graph, there are two conditions that need to be met for it to be proportional. The first is it makes a straight line. The second thing is that it has to go through point 0, 0. And that's because for this equation to be true, if x is 0, y has to be 0, regardless of what number k is. So in this first example, is it a straight line? Yes, it is. Does it go through point 0, 0? Yes, it does. So is it proportional? Yes, it is proportional. Now, in the second one, is it a straight line? Yes. Does it go through 0, 0? No. So this one is not proportional. All right, for proportionality to exist in a table, we have to say that our y value to our x value, the ratio of y to x, needs to be the same for each and every point in the table. So this y to that x needs to be the same as this y to that x, and so on through the whole table. So let's try that with the first table. And I'm going to take negative 8 and find the ratio of negative 8 to negative 2. So I have negative 8 divided by negative 2, and that would equal a positive 4. And the next one I have 4 to 1, the ratio of 4 to 1, or 4 divided by 1, and that would give us a 4 as well. And the next is y to x is 12 to 3. So 12 to 3 would give us, or simplify to a 4. And then the last one I have negative 16 to negative 4, my y to my x, negative 16 to negative 4 would give me a positive 4. Because all of these are 4, this is a proportional relationship. And my value for k is 4, which also means my slope is equal to 4 if I were to graph these points. Now let's look at the next table. All right, on this table, again, I'm going to compare my y's to my x's. So I'm going to take negative 30 divided by negative 5, or negative 30 to negative 5 would be a positive 6. And then I have negative 12 to negative 2. So negative 12 to negative 2 would also be a positive 6. And then I have negative 20 to negative 4. Negative 20 to negative 4 will simplify to a 5. Not the same. But let's just try the last point, just to finish out the table. I have negative 36 compared to negative 9. So negative 36 to negative 9, this one is a 4. Because these are not all the same value, these are not proportional. And if we graphed them, they would not go through the point 0, 0. The last representation for proportional relationships are equations. And equations are used to represent the entire proportional relationship regardless of what you can see visually. So within a graph, you're limited by what is shown in your x and y axis and what is shown in your table as well. If you want data beyond what is shown, you need to have another vehicle, and that's where you get this equation for direct variation, which is y is equal to k times x, where k is equal to the constant of proportionality. It's also a special kind of slope. It's the slope that is associated with direct variation. So if I look in my graph, I can find this point, and I define that point as the x is 5 hours, and if I go over to the y-axis, it's 6 miles. So I have 6 miles for 5 hours, and I can simplify that to 1.2 miles per hour. So then the equation would be my y. In order to find my y, I multiply my x value times 1.2. That's the equation for this graph. Now what about in the table? Well, in the table we previously found that the ratio of y to x was 4/1. So the equation would be y is equal to 4x. So whatever value x is, y would be 4 times that. These two are the equations for each of these representations, so then you can use it to find any value of y given the x.